In 1929, the American economy collapsed into an abyss. Within weeks, fortunes vanished, banks locked their doors, and a paralyzing wave of despair swept across the nation. The smell of panic hung over entire cities. Wall Street brokers were jumping out of office windows, and parents could not look their hungry children in the eye. It was one of the worst economic disasters of the 20th century, and at the center of the recovery was a bizarre, unexpected cure. It was not financial aid. It was not a government jobs program. It was a crisp, bubbly beverage in a heavy glass bottle, marketed under an incredibly strange name. Bib label lithiated lemon lime soda. Mothers bought it by the crate and poured it into the bottles of colicky infants. Broken businessmen drank it by the gallon to soothe whiskey-soaked hangovers. The advertisements promised it would purify the blood, stabilize the nerves, and bring instant happiness to a broken household. And it worked well enough that it became one of the most successful commercial products in human history. We still drink it today under its modern name, 7-Up. That was 1929. But the story of lithium starts billions of years before any human ever popped open a bottle of soda. Most of the elements we encounter every day, the iron in your blood, the calcium in your bones, the gold in jewelry, were forged inside dying stars. They are the byproducts of stellar evolution. But lithium is different. Lithium is older than any star that has ever existed. Along with hydrogen and helium, it is one of only 3 elements created directly during the Big Bang itself, floating through the black vacuum of space before the first galaxy ever assembled. It is, in a literal sense, a ghost from the beginning of time. It is also deeply strange as a physical object. It is the lightest solid metal in existence, so low in density that it floats on water. Its texture is soft as cold butter. You can cut it with a simple kitchen knife. But drop a piece into a glass of water and it does not dissolve. It hisses, spins violently across the surface, generates clouds of caustic vapor, and bursts into brilliant purple-pink flames. Beneath that soft silver surface is a chemical monster that cannot exist in pure form anywhere on the open surface of our planet. Humanity did not even know it existed until 1817, when a Swedish chemist named Johann August Arfwedson found an unknown alkali metal hiding inside a mineral sample from an iron mine on the island of Utö. He named it lithium, from the Greek word for stone. And for the next century, industrial chemists stared at it and had absolutely no idea what to do with it. Too unstable to build with, too flammable to store safely, too reactive to leave on a workbench. For over 100 years, lithium sat in sealed laboratory jars like a dangerous curiosity. Then came the madness. By the mid-20th century, psychiatric institutions had become houses of horror. Doctors had no reliable way to treat acute mania. Instead, they relied on physical subjugation, canvas straitjackets, padded isolation rooms, freezing ice baths, and electroconvulsive shock applied to the temples to induce violent seizures. In 1948, an Australian psychiatrist named John Cade wondered if everyone was looking at mental illness the wrong way. What if mania was not a psychological flaw, but a chemical one, a toxin in the bloodstream? He set up a primitive laboratory in an abandoned hospital kitchen and began injecting guinea pigs with various chemical compounds. When he added lithium urate to the mixture, something remarkable happened. The animals went completely still. They rolled onto their stomachs and stared back at him with glassy-eyed tranquility. Cade believed he had found the chemical dial that could silence human suffering. He rushed to treat human patients. Manic individuals who had not spoken a coherent word in years suddenly woke up and held calm conversations. But Cade had made a catastrophic error. The guinea pigs were not calm. They were poisoned. Lithium has an almost impossibly narrow therapeutic window. The difference between a dose that stabilizes mood and a dose that shuts down your organs is nearly microscopic. The animals were simply too nauseous and physically weakened by heavy metal toxicity to move. Cade had mistaken systemic poisoning for a medical breakthrough. Before the scientific community could pass this, lithium collided with a dietary trend and killed people at scale. In the late 1948, cardiac patients were being warned that table salt was destroying their hearts. Food companies raced to find a sodium-free alternative. Lithium chloride tasted almost identical to salt. It was marketed as a life-saving breakthrough, and millions of heart patients began sprinkling it over their meals every day, with no idea what they were actually consuming. Because lithium mimics sodium in the body, their kidneys held onto it instead of excreting it. Within weeks, thousands of patients experienced uncontrollable shaking, blurred vision, violent vomiting, comas, and sudden cardiac failure. The Food and Drug Administration banned lithium from all consumer products in 1949 and scrubbed it from supermarket shelves. It was branded a lethal, uncontrollable poison. This decision seemed small at the time. It was not, because while the medical world was banning lithium, the military was quietly building it into the most destructive weapon ever conceived. By the early 1950s, weapons designers understood that a fusion bomb, a hydrogen bomb that fused light atoms together, could be thousands of times more devastating than the atomic bombs dropped on Japan. The problem was the fuel. And then physicists noticed lithium. If you combined it with deuterium to create a solid powder called lithium deuteride, you had a compact, stable core that could fuel a thermonuclear blast. On March 1, 1954, at Bikini Atoll in the Pacific, the United States military tested this concept under the code name Castle Bravo. The scientists were confident. The bomb's core contained two lithium isotopes, lithium-6 and lithium-7. Their calculations assumed only lithium-6 would react. They predicted a yield of 5 megatons, enough to erase a city, more than enough to prove the concept. They were catastrophically wrong. When the trigger detonated, the supposedly inert lithium-7 absorbed fast neutrons and instantly decayed into additional fuel. The chain reaction went wild. The bomb did not yield 5 megatons, it yielded 15. 3 times more powerful than the most sophisticated physicists in the world had calculated. Military observers reported the sky did not look like a sunrise. It looked like the entire horizon was being torn open. The blast vaporized entire coral islands and carved a 2-mile-wide crater into the ocean floor. The fireball stretched 4 miles across the sky. And then, the wind shifted. Millions of tons of radioactive coral sand were pushed into the upper atmosphere and began drifting across 7,000 square miles of the Pacific Ocean. Hours later, white, chalky ash began falling like snow over inhabited atolls. Children ran outside to play in it. They rubbed it into their skin. They caught it on their tongues. Within days, their hair fell out, their skin blistered, and their thyroid glands began to mutate. The lightest stone in the universe had just triggered the worst radiological disaster in United States military history because someone misread the basic physics of an alkali metal. Today, lithium has been beautifully rebranded. It is no longer a dangerous soda additive, a volatile psychiatric experiment, or a thermonuclear bomb fuel. It is the essential material of the green energy transition, the element inside every smartphone, laptop, and electric vehicle on Earth. More than half the world's lithium reserves sit beneath the salt flats of the Atacama Desert. To extract it, mining companies pump ancient brine to the surface and spread it across evaporation ponds that stretch for miles. 2 million liters of water must evaporate for every single ton of lithium produced. In the driest place on Earth, this industry is draining water reserves that took millions of years to accumulate. And they are not coming back. The Licanante people have lived on the edges of the salt flats for thousands of years. They have watched the flamingo populations as a measure of the desert's health. Since lithium mining expanded, flamingo populations have dropped by 10%. The lagoons their communities depended on for livestock have dried up. The salt flat itself is physically sinking, subsiding by up to 2 centimeters a year as the water is pulled from beneath it. A community leader in the Atacama recently put it simply, "While mining companies are driving electric cars in Europe, out here in the desert, they are leaving us without a single drop of water to wash our faces." When the world's leading electric vehicle manufacturers were independently evaluated on how well they respect the rights of these indigenous communities, the average score across the industry was a staggering 6%, not 60. 6. A volatile rock forged at the dawn of the universe, found in a Swedish mine in 1817, and dismissed as useless for a century. Poured into a soda bottle to calm a depressed nation, and fed to infants. Accidentally weaponized as a dietary supplement that killed cardiac patients by the thousands. Weaponized deliberately into a bomb that detonated at 3 times its expected force and rained radioactive snow on children who did not know what snow was. And now, rebranded as the clean conscience of the modern world, while the desert where it comes from slowly sinks into the earth. It leaves us with a haunting realization about the true nature of human progress. Because as we race into a flawless, high-tech future, we have to wonder, how much of the world are we quietly destroying just to keep our own screens bright? If this story changed how you look at the devices in your hand, hit like and subscribe to the channel. Every week, we peel back the hidden histories of the things we use daily, exposing the dark pasts and the true costs that no one else is talking about.